morning, everyone. My name is Charles Fan. I'm co-founder, CEO of MemVerge. And today I am going to talk about big memory in multi-cloud. So as we have seen over the last 10 years, there has been a rise of modern applications that are dealing with data that are both big and fast. They come at the size of hundreds of gigabytes or even terabytes, and you need to process them real time. And these applications, including machine learning, simulations, video rendering, AI, financial analytics, scientific computing, et cetera, et cetera. And they are growing at an exponential rate. And the current infrastructure, whether it is on-prem or the cloud infrastructure that we are going to, is having a hard time to keep pace, to satisfy the requirement of these applications. And there has been a number of challenges identified, including, number one, memory being too small, that you cannot fit these data into memory, thereby you have to move them to storage back and forth before they can be processed. And then associated with that, you have the problem of storage being too slow, that once it needs to move to storage, they incur I/O, and that greatly slow down the processing of data by these applications. And for the customers who are moving to the cloud, you have a number of challenges there as well. You have a cost problem, as we have found out, as well as many of the customers. Cloud is not cheap, especially when you are moving heavy workload with many nodes, with a lot of data out there. It's actually more expensive than buying the servers on-prem. Yet cloud offering certain advantages, and how do you take advantage of the cloud without incurring the higher cost? So that's a challenge that many of the enterprises face today. And then if you are moving to the cloud, how do you have a bursting solution that allow the workload to work across a hybrid cloud that can work on-prem during normal time, and during peak time, the workload can burst into a cloud service. And that has been a challenge for these data-intensive applications as well. And last but not least, as we're entering a multi-cloud era, when there are multiple cloud service providers that can satisfy my need, the ability to move between them is not straightforward. There is an effect called cloud locking, that once I chose a certain cloud and had my workload being run there, it is very difficult for me to move it. So these are among the challenges that the operators and the owners of these data-intensive applications face. And so how do we solve it? So MemVerge has been working on big memory software over the last 5 years. And starting last year, we are starting to move to the cloud to allow our software to deliver application services that can resolve in some of these challenges for the enterprise customers. And this is especially become more important as we are seeing the emergence of a new standard, and that standard is CXL. I think there are other sessions that's going to go into more details about CXL, and this is a very exciting development that can potentially enable a new memory tier that's connected through this CXL interface that can deliver higher capacity of memory being available to the applications, as well as higher bandwidth that allow the PCIe bandwidth to be used in addition to the DDR bandwidth that's available to a computing system. So we believe this is a real game changer this can create a memory bus that can interconnect a heterogeneous pools of compute and heterogeneous pool of memory. And in general, a hierarchy of memory will emerge where you have the higher bandwidth memory at the top of the pyramid. You have the regular DDR connected memory at the middle of the pyramid, and then you have the CXL connected memory at the bottom of the pyramid that provides the capacity and bandwidth extension. And there are a number of new hardware that are emerging, including what's being done on the CPU side. Both Intel and AMD's new platform are going to support CXL 1.1 by the end of this year, and they're going to move to 2.0 and 3.0 in the coming years. And this also includes new CXL memory expander card from the leaders in the memory space, such as Samsung, Micron, SK Hynix, and so on. And this also includes new CXL interconnect that are emerging, done by various hardware startups. But hardware alone is not sufficient. There need to be software, really, to take full advantage of the capabilities that are provided by CXL. And ideally, this software can take advantage of these new hardware development, both on-prem as well as in the cloud. And that is the direction MemVerge software is going. And what we are delivering is what we call a multi-cloud memory as a service. It is sort of a memory operating system for the cloud. And what does the operating system do? It does really two things when you're talking about OS. One is it manages the physical resources, compute, memory, storage, networking, etc., and it kind of harnesses them and assembles them and compose them and make them useful to the applications. And second, it enables the applications in making sure the applications can be installed, deployed, and run and managed well on this platform. And that's what the operating system does. And our aspiration is to deliver that service to the cloud applications by harnessing the memory resources and pool them and tier them and providing the right data services on top of them so that we can deliver the necessary data services for these data-intensive applications in the cloud. And this is especially useful when you have CXL and other tiers of memory become available as part of the memory hierarchy. So let me dive into more details in terms of how our software will work and how do we get there. So this is the sort of roadmap of getting to our memory as a service, and it's going to be a multi-year journey. Coming along with partnership with all the hardware makers, the entire CXL ecosystem that we are working with, that we want to support all the devices well and take advantage of all the nice innovative features those hardware brings and bring them to the applications in the most easy to use manner. And we're going to deliver various interesting capabilities, including capacity expansion, including transparent checkpointing, including other memory services to the applications without requiring application change. So really we are delivering the composable memory and along with it, intelligent memory services to the data-intensive cloud applications. And the product that we have shipped since September of 2020 is a product called Memory Machine. And this is really the first step of delivering this multi-cloud memory as a service to the customers. What Memory Machine does is two things. It does memory virtualization with intelligent auto-tiering between different tiers of memory. And it does it through user space software by intercepting the necessary memory calls and dynamically place memory on different tiers. And intelligently monitor the access patterns and demote and promote memory pages as necessary. And we can do so without application change, and we can do so by minimizing performance impact. And this is a technology we have on the market for over a year and a half, and a number of customers are taking advantage of this capability. The second feature that we provide is we call memory snapshot service. And this is a innovative, first of its kind software that we have written on top of our memory virtualization. And this does not require any special kind of memory. It would work on any of the server system or any of the cloud instances today, that we would be able to capture a running application process at a point in time. And we would capture all the memory state or the CPU state or the OS state that are necessary to restart this application anywhere at any time. And on top of this snapshot capability, that a number of interesting features we can deliver, which including a time machine for an application, allow you to roll back to any of the previous snapshot that has been taken. We can also restore the application either at the same computer, same instance, or at another computer, another instance, even on a different cloud. And we can clone an application on the same server by really sharing the physical memory between these clone instances and fork them for the memory pages that are different. And we are tracking different snapshots only by tracking the deltas, therefore minimizing the memory overhead through this technology. So this is a quite magical piece of software that can enable enable these interesting capabilities to the applications that weren't possible before. So those are the two features of a memory machine that we have been working with customers for them to deploy over the last 18 plus months. And now let me go into some of the typical use cases, how customers are using them in their environments. The first example is memory capacity expansion. And this is to use our memory virtualization underneath a KVM hypervisor to expand the memory footprint for this infrastructure, thereby increase the number of VMs that they can place per server and reduce the per VM cost, increase the consolidation ratio, and lower the overall TCO for this cloud service provider customers. And we actually have multiple cloud service providers who have deployed this solution to increase their memory footprint on their servers and reduce their cost. And we can run this above multiple types of memories, including DRAM, including Optane memory by Intel, also including the up-and-coming CXL memory for our customers. And one key point we can do here is that we can enable all the applications inside of a virtual machine on top of the KVM hypervisor, and we can minimize the performance impact from this memory virtualization. And this is just one example of running MySQL database inside of a KVM virtual machine. And on the left-hand side, you see the baseline running with DRAM. And with that, you see 47,000 query per second. And all the bars, or all the columns next to it are running with our software with a mixture of Optane persistent memory and DRAM. The 37,000 query per second were obtained by using just Optane memory alone. And Optane memory is a bit slower than DRAM. Therefore, you get 20-some% performance degradation as expected. And as we increase the amount of DRAM we add to the PMAM, you see the performance start to increase to the point where it equates with the performance of the baseline. And so this is a case where we can dynamically change the DRAM and PMAM ratio to find a good ratio that give you the acceptable performance that either slightly below on par, and in this case, even slightly exceeding the baseline. The reason in this case it can slightly exceeding is because we are using our memory allocator with a more aggressive use of huge pages that has a little higher performance than the operating system memory allocator. Now, this is not true for all applications, but for some applications that we can see this performance improvement. So that's the first use case, is by delivering the virtualization with tiering, that we can deliver larger capacity to lower the total cost of ownership for the cloud service providers. Now, the second use case is for financial customers and other customers who are using large in-memory databases or in-memory applications. As memory become larger, the need to protect against failures of these memory become more important because the blast zone become bigger. If you lose a node, you will lose a lot of data, hundreds of gigabytes or even terabytes of data. It takes a long time to recover. Now, with our in-memory snapshot, we can do that protection at a much more efficient manner and dramatically reduce the RTO, the time it requires to recover from failure if a failure occurs. And we have an example here, which is with a financial customer using Redis database, a 315 gigabytes with 300 million keys, without us using Redis's own RDB recovery mechanism to recover such a database from a server reboot would take 15 minutes. So you would wait for 15 minutes after server boots up, and then the database is recovered. Now, with our solution, in conjunction with Intel Optane memory, which is a persistent memory, and by taking snapshot of this database, the recovery become half a second. So after the server is rebooted, it just takes a half second to restart this database because the data is already in the memory. It's captured by our snapshot. So this is a dramatic 3 orders of magnitude improvement in terms of the time it requires to recover from such a failure event. And so that's the second use case. The third use case is with the scientific computing workload. And we actually working with quite a number of genomic companies in this area where they are performing multi-stage data analytics on their genomic, doing the genomic sequencing work. And this example is a genomics research company doing single cell research, and is going through multi-stage of computation, and sometimes needs to branch, sometimes it needs to roll back and rerun to reproduce results or do what-if analysis. Without our software, after each stage, it is doing a checkpointing to storage that's necessary to keep the state, so that allow you to roll back and to reproduce or do what-if analysis. And for these type of workload, this checkpointing to this can be very time-consuming. So, for example, we are using a mouse cell atlas to do this sequencing work. It is going through 11 different stages, and for each of the stage, it is doing a lot of computation work. It is also doing a lot of I/O because this checkpointing. Now, what we do is we use an in-memory snapshot to replace the storage checkpointing work, thereby dramatically improve the transaction time for each of the stage. In some of the stage, we can improve about 20%. In some of the stage, we can improve about 20 times. That depends on how much I/O, how much time is spent on I/O in each of the stages. We can pretty much eliminate all of those running time that's spent on I/O. So overall, for this example, we can save about 2/3 of the running time. What used to take 12 hours now takes 4 hours to complete. And this is if you just run it forward from stage 1 to stage 11. What is even more dramatic improvement to the productivity is if you need to roll back. Before it takes 10 minutes, it takes 15 minutes to roll back because you need to load that checkpoint from storage to rerun it. Now it just takes 1 second for you to roll back to any of the previous stages, do that snapshot, and run it again. So this really accelerate the discovery time and shorten that time to results for these genomic researchers and bioinformaticians and biologists who are really finding cures for cancer, for COVID, and for all those things we care about. So we are very proud to be working with those folks to accelerating their time to results and increase their productivity. Now, last but not least, I like to share a new use case that we discovered over the last year in terms of bringing these big memory technologies to the cloud through a concept we call app capsule. And this is to combine our in-memory snapshot technology with cloud native orchestration. And what this would allow are multiple things. Number one, it can provide protection to a running application in the cloud so that even if you have a long-running stateful workload, now you can take advantage of a low-cost spot instance in the cloud that had up to 80% discount compared to a regular on-demand instance. There used to be a catch, is that with a spot instance, they can take it away. So if you have a long-running, non-fault tolerant stateful applications, then you are in bad shape. You have to restart the application from the very beginning. And if you're 2 weeks into the job, you just wasted 2 weeks of work. Now with our app capsule protection, we could have a periodic snapshot being taken and have that encapsulation of the application being moved to a storage service. So if you have such cases where spot instance being taken away, then we can recover that running workload in another instance. So you don't have to lose 2 weeks of work. You maybe just lose 20 minutes and then just continue the workload while taking advantage of the cost savings. So that really provides a dramatic solution to the cloud cost problems. It can also solve the mobility and bursting problems by providing these app capsules and allow the applications to dynamically move from a cloud instance to another cloud instance or from an on-prem server to a cloud instance without really creating major interruptions to the applications. So by applying our big memory technology on the cloud, we are really solving all of these problems I listed earlier, that we can make the memory bigger and solve the memory too small problems. We can eliminate those storage IOs and replace it with a memory access that are much faster, up to 2 or 3 order of magnitude faster compared to storage. We can solve the cloud cost problems by protecting the spot instances and allow stateful long-running workload to run in spot instances. And we can enable cloud mobility and cloud bursting by using our app capsule technology as well, and moving those long-running applications from one cloud instance to another. So we are only beginning on this journey, and the future looks very bright. If we look forward to the next couple of years, we think the CXL ecosystem will become real, and there will be more hardware choices that can add to this big memory ecosystem, both in the cloud and on-prem. And especially with the future CXL 2.0 and 3.0 specifications, that we'll see the pooling and sharing and cross-node tiering of memory made available to the computing nodes. And there need to be newer, interesting software with additional data services being provided to that new architecture, very similar to the software that was developed 40 years ago for Fiber Channel. And so we're going to see very interesting software innovations in this CXL space. And then those data services, they need to be ready to be made available to the applications, both on-prem and in the cloud, in the form of infrastructure memory as a service to the running applications, especially these type of data-intensive modern applications. And through big memory software, you can enable these applications and deliver them higher mobility and higher availability across a multi-cloud. And this is a very exciting journey, and we are certainly not doing it alone. We are working with a portfolio of very strong partners who are leaders in the space. We have been working with Intel and now AMD to support their CXL implementations. And we are working with leading memory vendors, with Optane, with the new CXL memory to support their memory products. And we are working with the software partners, including Red Hat and VMware. And we are working with the system partners like Penguin Computing. And we are working with the new class of PCIe and CXL switches to support the interconnect of CXL as well. And we are open to more partnership in delivering big memory solutions to the enterprises. So thank you for joining this session with us. We believe the future for big memory is bright, and especially as a CXL is coming to maturity and multi-cloud is taking over the world. And we look forward to collaborate with all of you to bring this vision to reality. Thank you very much.